I'm gonna bring this up. So 05 September 23rd, NRA. Okay, so we are going to do a few things today. It's gonna, unfortunately, it's gonna be kind of a boring day because I'm gonna go through some obvious stuff that most of it is known from OOP345NRA, and kind of fill in the blanks and make sure everything is good, and show you some examples of templates and aggregation, association, and composition, and that's going to be the day. And after it's done, we are up to date with our weekly schedule. Okay, you have a lab on Sunday, right? You have a lab on Sunday, or you don't know? Okay, so whatever. The next lab that you have, the day that you're coming to to class, you're going to have a quiz, and you're going to see what the specs of the quiz are. I'm going to send it a couple of days in advance. So if you have it on Thursday, you're going to receive the notification today. If you have it on Friday, you're going to get it tomorrow. And you're going to know what the quiz is. Also, if you look at the subject, there's a new thing added over here. It's just for something that I want to no, actually, I cannot put it like this because student information is going to come up. If you, let me just go to content, NRA. All right, so if you look at here, there is something called attendance. You see that? That attendance is a quiz. So it's essentially it asks that I'm present today. And you click yes when you log into it. When you are in person over here, I'll ask for your names and I add it. But for those people who are at home, somewhere halfway through the lecture, I'm going to say, open up the attendance and check it. And I'm going to give you a code and you'll do it. And that registers your attendance so I can add it to the marks. If you look at the marks, you already have an attendance mark over there based on the quiz you have done in the lab. So like this, I'm gonna, this attendance that I'm taking, it has no negative effect on your marks. So which means if you're confident that you can do this without me, no problem. Don't attend, don't do anything, just be at the quizzes at the final, get your A+ and go and enjoy your life, okay? But if you are in need of help at the end of the semester or at some critical time, and I see you have never attended a class, and now you're coming asking for help, priority is going to be for those students who actually attended the class. Okay? Just letting you know. It has no negative effect on a mark. I'm not going to reduce anybody's mark, but I just know who comes to class and who doesn't. So when I tell you in the class that, okay, online people, please open up the thing. Make sure you have this thing open now on the background because the length of the class is, the quiz is only 1 minute. You're just clicking on true and that's it, and you submit. 1 minute you have. After that, it gets closed. And you have that chance to set your attendance so I know that you actually were in class. This is something that I have to do because if you look at the number of people who attended the quiz and got feedback from me is, I'm going to just take a look at, if you look at your, it moved down again. If you look at your gradable items, quiz 0 is, so 10 is missing. Out of 20 who submitted, half of the class did not take the quiz. So it means they weren't even in a lab at the day. Okay, so again, and 4 is missing for practice and agreement for programming quizzes, which means I actually am going to extend that. So let me just go back to the content. I'm going to open up the quizzes, practice and agreement for programming quizzes. I'm going to set the due date to tomorrow night, 11:59, so I'm extending it. Remember, if you don't do this, then you won't be able to do the quizzes or anything. It's prerequisite for anything done in the class. So you need to make sure that you actually have this done. And that's that. Okay, before we begin, do we have any questions? Okay, we're going to go back to OOP345. I'm going to bring back something that we have done in OOP345, an example of a class written in OOP345. Obviously, I have two things added over here that are not OOP345, the move constructor and move assignment. I'm going to walk through this to kind of tell you what it is.
Sorry, sir.
Pardon me?
I was having issue with starting my system. That's why I came late. I did not get the code for the attendance.
Excuse me, I didn't get that. Victor? Yes.
Yeah, I was having issues with starting up my system. That's why I joined late around 1:30.
That's why I extended it extended for tomorrow night. So.
But I don't have the code. It's asking for a code for the attendance.
Code for attendance.
Yeah, it says start attempt. It's asking for access code requirement.
My dear, you didn't get what I said. Okay, that attendance thingy that you see, it's not going to get open. I tell you when it's open, and you have 1 minute to finish it. It's going to be halfway through the lecture, somewhere, whenever I have time. It has nothing to do with it right now. So when the time comes up, I'm going to say, please log in and do your attendance, and that's it. And this is the code, and I'm going to post the code on a screen. So you have the code, you do the attendance, you have 1 minute, and you're done. Not now.
All right.
Okay.
All right. Yes, sir.
Okay, and thank you for clarification.
Okay.
All right. All right. So that's that. Yeah, so let me just make sure that this is okay. Give me a second. Okay, yeah, so I am going to remove the move constructor and move assignment from here, and we're gonna do this later, not now. We're gonna add it later, but for now we let it be as it was in OOP345. So essentially, what you see over here is a class, my attempt in OOP345 to kind of fix the problem with arrays in C language. In C language, arrays have problem with arrays that, first of all, the size, you're stuck with the size when you create an array. If you have 5 elements, you have 5. If you have 10, you have 10, and you're stuck with it. You cannot change the size unless it's dynamic, which we don't want to do. We want it to be, so essentially it's a class that removes that complexity of dynamic memory allocation. Number two, what this does is that unlike arrays in C that are not aware of their size when they are passed to another scope, this one will remember what its size is. Quickly explaining what it is, we're going to go through it. So step one, an array has a pointer that points to the beginning of the information in the memory. So M data essentially is the beginning of our dynamic array. Size will remember what the size was, and it's size T. Resize resizes the array on demand, which means when if I'm not satisfied with the size that I have, I can simply call resize with a new size over there. It resizes the array to that size, copying the old information in, either shrinks it or expands it, whatever. So essentially it resizes the array. I have a constructor that defaults everything to 1. I have, what shall we call it? I have a copy constructor that copies another array. So it solves another problem with arrays, that when you had an array to copy one array to another, first of all, you had to make the sizes to be the same. Then I had to go through the elements one by one. So we don't have that problem. It copies everything from one array to another, and also the assignment copy assignment too. It always knows what it is size, so whenever you call the size function, it returns it. You can access the elements using the index operator exactly like an array in a read-write manner, because it returns a reference of the element of the array, so it's done. And also, if you pass the object of an array as a constant to somewhere else, the index operator is overloaded, so it can actually work with a constant object too. It returns a reference of a constant object, constant element, so it's got to be read-only. I have a virtual destructor in case you want to, extend this to another class, or you want to inherit off it. Just for fun, I added a display, so if somebody inserts the array into OStream, it's going to print it comma separated. Okay? How it's implemented is as follows. So essentially, when somebody wants to create the array, it looks at the size. If the size that they pass is 0, it makes it 1. It means if they create an array, it's going to have at least one element. Then it allocates dynamic memory exactly to the size that we want and sets the size at the same time, and sets M data to the dynamically allocated memory. If at any part you feel there is a problem or you don't understand it, stop me, because it's 244, I'm going quickly, okay? The copy constructor, what it does, it allocates to the exact size of the other one, and the one that is copying, and then copies everything one by one through a loop from the other one here. So essentially makes all the dynamic memory allocation encapsulated inside the int array, so the programmer who's using this doesn't have to deal with it. The assignment operator, if one array is set to another array, first of all, it makes sure that it's not self-copied, self-assigned. Then it deletes the current data not to have memory leak, and then follows the exact same procedure as the copy construction to allocate and copy everything, and returns the address of the current one for cascading purposes. When the array goes out of scope, it deletes the data, makes sure there is no memory leak. It always tells you exactly what the size is if you want to. It passes, when you pass an index to the index operator at line 33, it checks the index. If the index is less than size, it simply returns the reference of the current element. But if it's not, it calls the resize method to just resize it. So if you go past the size of the array, it automatically expands the size of the array. But when it comes to constant version of it, because a constant array is not supposed to expand, it says if you give me the index that is greater than size, I'm just going to send the mod back. So if the size is, for example, 5, and you give 4, 4 mod 5 is 4, so element with index 4 is returned. But if you hit the size, which means you're going out, 5 mod 5 becomes 0, then it loops back to the beginning. If it's 6, it becomes 1. If it's 7, it becomes 2. If it reaches to 10, it becomes 0 again. So no matter how big the index is, it always stays within the range of the array, and therefore you're safe. So essentially, you only shoot yourself in the foot and no one else's. And because we have the size, and size tells us what is the size of the array, we need to be responsible not to go more than that. So it just silently waits over there. Display simply shows the first element because it at least has one element. Then it starts from 1 up to size. 1 by 1 shows everything comma separated. As simple as that. So it shows all the values comma separated. And returns the O string. What resize does, first it allocates enough memory to the new size that you want, whatever it is, smaller or bigger, it doesn't matter, and holds it in temp. Then it starts a loop going up to size or new size, whichever is smaller, and copies everything from the old data to new data. Therefore, if the new size is smaller, it truncates the array to the smaller size. If it's bigger, it just goes up to that much. The rest are set to 0. Or defaulted, because we are not mentioning it. Then it actually sets the size to the new size, deletes the old data, and makes the data point to the new one, and therefore it's resized. And the operator overload for OStream allows insertion into cout, and therefore, because of this, when I write something like this, when I write something like this, for example, int array, I say 5, or 4 is fine, 4. Then I can go for size t, I set to 0, and I less than, I can go size of I, so I can actually do this, and I plus plus, I plus plus. Now I'm going to say I at index I will be equal to I plus 10. Just put some values in it. And in here I'm going to say cout I. So doing so, it's just going to show 4 elements for us. I'm just going to compile and run it. So what you're going to see will be 10, 11, 12, 13, and 12 and 13, 4 elements. The good thing is that if I don't put size over here and say put over here 20, it's absolutely no problem. It's going to expand the thing as it goes up. So Control F5 over here. Again, one more time to run it. We'll see that it actually expands up to 20 integers. There's absolutely no problem. Any size that you deal with is going to resize itself accordingly. Obviously, I can have something like, I'm not going to go through everything, but if I have an integer array j, I can set I to j, fine. I can pass something by copy, fine. Everything's going to be fine with copying and everything. Now, when we have this, understanding the logics that we have in OOP345, we need to add move constructor and move assignment to this so it can be moved around if needed. To do that, we know what the signature is. So for the move constructor, I'm going to write int array, and I'm going to receive an int array right reference. So I'm going to call this one move. That's that one. And for the operator, I'm lazy to write it, I'm just going to copy the operator exactly the same. So C and V. The only difference is that it's not going to pass a constant, and it's going to be a one that is going to be moved. And obviously, as I mentioned, please add over here no exception. We'll explain what it is after, I think, midterm or something, when we learn about exception handling. Okay, so these two are created now, and all I need to do is to create their definition. So I'm going to bring it over here. So if I want to move, what I would do over here is saying, okay, the one that is being moved is MV. The current one is supposed to take care of that one. Because it's a constructor, int array doesn't have any data. Therefore, I can freely write m size will be set to move.msize. And mdata will be set to move.mdata. So now both objects are pointed to the same allocated memory, whatever it is. Now I need to make the other one lose it. We know by our definition, if you look at line 6, we don't have an empty array, and an empty integer array has only one element. So that's what I'm going to do. In here, I'm going to write move dot mdata. Instead of setting it to null, where I'm usually moving, because the empty version of an integer array is 1, I'm going to say it will be equal set to new int 1. And why I'm writing new int 1 and not just new int is that because it has to be an array of one element. So when it's deleted with square bracket, it's not going to fail. Okay? Remember that there's a difference between an integer and an array of one integers. An integer is just one integer, but an array of one integer is one integer pointed by another one, by a pointer. Remember that. Okay? So that's that. And for the size, m size will be set to 1. I think that's it. Yeah. So that's moving. And by doing something like this, the current object will take ownership of the moving object's data and sets the other one to an empty one. And I can do the exact same thing for the move constructor. So as you see, I'm just copying the copy constructor that I have over here. And what I'm doing, I'm removing the constant. I'm going to call this one move. And it's got to be no exception. Everything is exactly like a regular move copy constructor. The only difference is that the copying procedure is removed and it will be changed to a moving. Why is it giving me an error in here? Am I making a boo-boo? Oh, my apologies. It should be an R value reference, okay? So, and I replace the code for copying for moving exactly from copying. So that's the difference. So in here, I would simply say, first delete my data, take ownership of the other one, set the other one to empty. So commenting it just to remember how things are done, delete current data, take ownership of other, set other data to empty. Whatever the empty is defined in that class. If that is supposed to be null, set it to null. In this case, it's not null. Okay? So now, move constructor is set for this one too, and this object can be moved as well. If I compile this, I just want to make sure that it compiles and everything's good. It's pretty standard, so I'm not going to check it, waste your time to run it. Go on home and test it. Now, we're going to get to the concept that we have learned last time, templates, class templates. This is an array only designed for integers. I want it to be for templates. If that's the case, then how it's going to work. Okay? So By the way, at the end of the template, right before we talked about expressions, we're going to take in attendance. I'm letting you know. Okay, so as we mentioned, to have a template, we must have everything inside a header file. So I'm going to add a header file over here, header file, and I'm going to call it array.h. Okay, that pragma1 thingy is the equivalent for the safeguards that we put. Well, we add the safeguards anyway to make sure it's backwards compatible. So I'm going to say over here, if not defined. Then in here, I'm going to say Seneca, array, and h. Okay, copy that. And change this one to define. Add the namespace. Now we are ready. So that's an empty header file. Now I want to create the array thingy in it. All the code for int array should come in here, everything. I'll come to the integer array. I'm going to grab everything that I have over here. I'm going to copy it and paste it right in here. That's number one. Okay? Obviously, I'm going to need IO stream. Okay? Now, please pay attention that I cannot write using namespace std here because this is a header file. Luckily, I have std scope resolution for IO stream objects and classes. Therefore, I don't need to make any modifications. But if you didn't have that, you had to add the std scope resolution to whatever you had. Then after this, I'm going to go to the CPP file and copy all the content from the CPP file and put it right over here. So copy, and I'll come down over here and paste. There we go. So everything is copied. I'll save it. I'm going to remove this, and I'm going to remove this. First thing I need to do, it's not an integer array anymore, so let's name it properly. It's going to be a regular array. It could be any type of array, so I'm just going to Control H this to find and replace. And I'm going to say any int array that you see in current document, change it to an array. So my object name will be an array. And I do that, and it's all changed. So now I have the array class. Are we okay with this? Step number one in converting a class to a template. You have to add the template statement to every single scope that you have in the file. Therefore, I need to come up over here and type template, type name, type, whatever, T type, whatever you want to put. I'm going to put type over there because it just makes more sense, okay? And I'm going to copy it. Then I'm going to go through everything over here and see what I have. So let's copy this. I'm going to come down. So this is where the scope ends over there. And I have over here a one-liner. I have a one-liner prototype. That's a scope of its own, so it needs a signature. And then I have this one. So I'm going to add the template to every single scope that I have, one by one. That's step number one. So essentially, I'm expanding my template. The type name doesn't have to be type for all of them based on syntax that we have, but it's a good idea to always keep the same type, not to get confused. What are you doing? Okay, so that's that. So everything is added over here. Okay? Next step. The next step is so step number 1, I'm going to actually write the steps that we need to do. So to convert a class to a class template, first you do the following. So, number 1, add the template statement to all the scopes, block scopes, let's say, all the scopes of the code. Okay, that includes classes, methods, prototypes, everything that you have. Now, after that, the second thing you need to do is to change the focus type of the class to the type. So we have a type over there, so I have to say over here, change the focus type. That is what the class is supposed to template. Okay? To the template type. Which essentially means this is an array of integers, therefore I need to change all the int elements to a type. Okay? So I'm going to kind of double click on here, and I'm going to go Control C. Now, oh, not that one, sorry. Copy it, and then I'm going to come down. So this is the type of the pointer of the array. It needs to be a type. Then I'm going to continue. Nothing over here is related to the type at all until I get to line 27. Let's say 28. At line 28, I am returning an element, reference of an element of the array. Therefore, that needs to be a type. I am returning, again, a constant reference of the element of the array. And that needs to be a type. And the rest is nothing. So I'm good. I'll continue with the rest. The prototype needs nothing. The constructor is creating literally the array, so it shouldn't be an array of integers, it should be the array of types. And the same thing over here. Actually, this is a very good example, good thing for a quiz. It's possible that I'm going to design something like that, give you a class and tell you convert it to a template and see how you do it. Okay? So it's a good practice. Okay, so for move construction in here, what I'm doing is that these are setting, there's no problem, but I'm creating a single integer, so that needs to be a type. For assignment operator, I am creating an array, that needs to be a type. For moving, it's exactly like the other one. Everything is not dependent to the type of the array other than the single one that I'm creating, that needs to be a type. Deletion has nothing to do with the type. The size doesn't matter. So whatever is the number of the elements, that's the size. It's always a size t. The return type of the index operator, both of them need to change. The display does not have anything to do with the type. Resizes it, so it needs to be an int, changed to a type. And this int needs to be size t because it's going through the number of the thing. So the integer is not correct. I didn't notice that. I just noticed it now. So this is new type, and everything else seems to be okay. and done. So step number 2 is done. Everything that is supposed to be templated, it is now. Number 3 is the tricky one. So you have to, we know that. Let me just first save this as int array main and bring up over here. So if you recall when we created the array last time, the array that we created, we said that when you create a class template, the class doesn't have a signature to dictate to the compiler what type of template should get created. Because of that fact, when you create a class, you need to add the signature of the signature of the template to the class. So in here, I'm going to have array.h. If I want to actually create an array of integer, I need to add over here an int. I need to change it like this. So now it becomes an array of integer, right? So when I want to do something like this, I understand that the class itself needs to carry the type. So I go back to the code and I look at the code. The third rule is going to be add the type of the template to all the template class names, except the following. So any place you see an array, you should put a less than greater than type and attach it to the array. Other than 1, the name of the class right after the template statement. So this doesn't carry it. Why? Because that's the name of the class. It has nothing to do with creating an array. So at any time, essentially, these rules, the 3 rules that I'm going to tell you, will separate the names of the class for the template that are not to create a template, but only to refer to the code. Because of that, the second thing would be the constructor names. The constructor names. Those will not get the signature. And finally, at the end, it is the destructor. So these will not receive the signature. Let's see now. So this won't get it. This type, size. This is the constructor name. It will not get it. This is the constructor name. It will not get it. This is the name of the array. It has nothing to do with construction, destruction. So this has to receive the type signature. When you think about it, it actually makes sense. Why? Because essentially it's saying which one I'm supposed to copy. Definitely you have to copy the one that is being created for. So if it's an integer template, the array of int should be copied, not other ones. So you need to mention what it is. The same thing for the move constructor. Which one I should move? In here, the assignment operator returns a reference of an array. It should tell me which one. And the one that it receives, we should know which one it is. The exact same thing. If it's not one of those 3, you add to it. Type. Destructor, we don't touch it. OStream has nothing. So down to here, it's fine. That single line, I have a type, it's printing an array. It needs to say which one I'm printing. So if you are creating an array of int, then the prototype for insertion into OStream for that one will get created. All the ownerships must receive the signature, but the name of the constructor will not. This is again ownership. This is argument. Ownership. Argument. The name of the constructor is untouched. Return type. Ownership. Argument will receive the signature. Return type. Ownership. Argument will receive it. ownership, destructor is not touched, ownership, 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 again, ownership, ownership, and at the end, the array that is supposed to get printed. And ladies and gents, we have ourselves now a template, class template can be an array of anything. Now I can go over here, not only I can have an array of ints, but I can have an array of, say, doubles. Oh, not that double, this double. Say D, and in here I'm going to put 5. Okay? So now I'm going to say over here, C out I, D, and I'm going to write a couple of loops over here. One is going to add to I, the other one's going to go add to D. For D, I'm going to make it a double, so it's 1, 2, 3, and I'm going to go up to 10. And then I'm going to show I and D and get out. So now, like this, I created an array of 2 different things, and it should work for all of them if I don't have a mistake. Oh, I do have a mistake. Size T of type. Oh, I have a mistake. I have to see what it was. So the very first two, it was something that I have to see what it is. But anyways, take a look. The top one, they are both empty, blank ones, which means they were not initialized. They have garbage in it. How can we fix that? Do you know? How can we fix so it's all 0? I don't know if you want it to be 0 or not, but you want an array to be all 0. If we want to do that, then all the, let me first see, what is this? Let's see. Size T to type, possible loss of data. Let me see, what do we have in? Oh, because it's size, yeah. The reason is that these are size, yeah. So the reason that we got that error warning over there is that the I over here is size T, and this is double. So that's not a right thing to do. So static cast int something like that. We need to make sure it is not a size T. I think this is going to be okay. But anyways, now if we want everything to be 0, what we need to do is to go to the memory allocations, and we can do something like this at the end. So by doing something like this, I am universally setting everything to 0. It's very simple. That's one of the good things about the new features of C++. This aggregation and creation makes our life very easy. So any place that I have something like that created, I can actually make it default like that. Where else do we have something? We have it here. We had a resize somewhere. There you go. I think now we'll be okay. So if I run it now, this is what we're going to get. Voila. Okay? So now I have 2 array of integer and double. You can have any type of array that you want. The only thing that you need to be concerned about is to documenting this, which means you have for this template that you have, you actually need to mention what are the restrictions that you need to oversee for this. So the type over here, it could be, I'm going to say, we'll go through it. So summary, it says creates an array of types, okay? Then the next thing we need to mention over here, type must support, then we have to go through it. So first of all, the very first thing that we see over here is that when you're coming in here, you'll see all the types are defaulted. So it needs to have a default constructor. So must support default construction. If you have a type that doesn't have a default constructor, this template cannot be created for used for it. Next one, I am setting one type to another. So assignment should be covered. So type must support assignment. So assignment, what else? Assignment. I don't think there's anything else. I'm not doing any copying, anything. So anything that can be assigned to another thing, and to be assigned to its own same kind, and it can be defaulted. You can do an array, create an array of employees. You can anything you want, okay? And that's an array template. One thing you need to be careful about. No, not careful, but just know about is that this is absolutely useless. We already in STL have a class called array that has everything. So what I created over here is just behind the scene of what happens when you're using the STL, which brings us to why we are teaching this. It actually goes to kind of, it gives two messages to you. Number one, the reason we are teaching this to you is that so you know what's happening behind the scene, and therefore you know when you are using the STL, what are the limitations and what you need to be careful for. When you know exactly how something is built, then you can use it better. That's number one. Number two, it tells us how to use AI. Now, you're going to say, what the heck? Why are we learning programming when everything can be written by AI, right? You can actually tell to AI, write this for me, and it writes it for me. So you are allowing the AI to guide you through whatever you want, to kind of take the wheel and go. But as soon as you see it's taking you over a cliff, you need to be able to take over. And that's the difference between a programmer using AI and a hillbilly using an AI. Okay? So what happens is that when you learn the programming, you know the right questions to ask. Therefore, you can actually program using AI. You give the task to AI, AI writes it for you, you look at the code, you approve it, you go to next. If you have no idea what's going on, you will make mistakes that nobody can debug, and you'll be in trouble. So unfortunately, we need to learn how to program properly to be able to use AI. There are self-driving cars out there. And you sit in them and the car drives itself, literally. I'm not joking, this is absolute reality. But you need to have somebody who knows how to drive to supervise. In case it's going to run over somebody's child, you need to be able to take over immediately. If you're not a driver, you cannot use a self-driving car. As simple as that. Remember, we are at the age of GAI, okay? General Artificial Intelligence. We are not at the age of AGI yet, Artificial General Intelligence. Artificial General Intelligence is science fiction now. It's the artificial intelligence that is multiple purpose and knows everything. All the things that you see, ChatGPT, these are all simulated. They are narrowly focused to do something for you. They are not really general yet. I don't know. Some people say we need another 10, 20 years. Some people say 2 years. Well, we don't know, okay? Just be aware of it. Are we all good? Questions? Yes, ma'am. Okay?
You can only pass one type to the class template, right?
Yes, at a time. I can use them, I can pass as many as I want as long as they're different arrays. So this is an array of integers, so I is an array of integers, D is an array of doubles.
But what if you had like,
And an integer and a double?
yeah, inside of the class, like as dynamic memory?
So what if I had this struct record, okay? Struct record, and in here I have integer A and a double B, you're saying, something like that, right? And and I'm going to say over here O stream reference operator, and what do I want to do? Operator, something like O stream OSTR, and at right side I'm going to have a const rec reference R. So now in here I can say C out. What can I say? C out. C out. I'm going to say over here R.A and R.B. Are we okay with this? So I can show a record. I can create a record and I can show it, right? So I can go over here, rec R, and in here I can put over here 10 and 20 and 30.3, and then I can go something like C out R, right? So when I run this, oh, built errors, why? No. Must return. Oh, shoot. Bad boy I am. Return. Okay, so now that's the 2030 thingy that I have, right? Okay? Problem with this? Now, one thing I forgot to mention over here, it was the third thing. In here we said must support assignment. The other one was type must be insertable. Insertable into OOP3. Now, when you look at this, let's take a look. Can one rec to be set to another? It can, right? Because there is no dynamic memory anywhere, right? I can create R, and I can create S, right? And I can say R is equal to S. I can do that, right? So assignment can happen. And if I just create an R by itself, it's going to be 0, right? So it can be defaulted, correct? So it matches the specifications. All I need to do over here is to say array of rec R and say 10. And here, I'm going to put it at the end over here. And in here, I'm going to put R. There you go. They're all zeros, but I still have them, and you can set it to whatever you want, right? So it's very simple and straightforward. There is no hidden agenda behind it. It works for anything. So essentially, if I wanted to have a loop and try to do the same thing, all I needed to do is to have something like this. So in here I could say this one will be Instead of I, I'm going to put R. And I'm going to say this is going to be a record of this and this. There we go. So now it's actually setting the R one by one to the first argument being 10 and the second one. And it keeps going through. As simple as that. Okay? All right. Okay. It literally is, as long as these three things can match any object, it could be anything. You can use anything. Let me just make sure that it compiles. If it doesn't compile, then I'm going to fix it. Yeah, it compiles. Okay. And it has lots of garbage in there, but hey, okay. Let me just make it shorter so it's actually visible. I made it 20. Let's make it 7. Here you go. Okay. And we have 3 zeros at the end over here. Okay. Any other question? Actually, thanks for the question. It's a good one. Any other question? People at home? Question? All right. So next step would be essentially going in here. So I'm opening the attendance, and the code for the attendance will be people at home, please insert this for the attendance and do the attendance. Meanwhile, I'm going to ask my friends over here for their name, and I'm going to mute my microphone while doing that, and then we'll continue. So please do the quiz, and if there's any problem, let me know. And you have 1 minute. So, my lady, your name?
Tara.
Tara. My friend? There we go.
Professor?
Yes.
Oh, it's okay. Sorry.
What's going on? You're okay?
Yeah, all good.
All right. Okay, so, and thank you. All right. So we are done. And we can kind of go for a break and come back, and we can go for a break, come back, and then we are going to start with expressions and give you an example of composition and stuff, and then we'll be done. Okay. It's a boring class. I'm sorry. We're going to have very good classes coming up soon. We're going to get to real stuff soon. So my apologies for all the boredom. Oh, let me pause recording. It's recording for no reason. Pause, Zoom, and all right, so let's talk about expressions, kind of a quick review of many things that we know and kind of fill in the blanks as we go through. But essentially when we're talking about expression is essentially anything that works with an operand and an operator. So any operator that you put in, you put two operands and an operand on the side, that's essentially an expression. And all the expressions and the precedence in which they get evaluated is extremely important, because not knowing it will create lots of nasty bugs, which we don't want to have in our system. We know about L value and R value. We called L value and R value, but essentially this is what it is. An expression is a generalized L value and an R value. And the generalized one, the reason they call this generalized L value and R value over here, because the L values standing at left, we know exactly what they are. You have integer A, we put A at left. The PR values that we have at right, we know exactly what they are. It's a literal value, 2, you put at right. What is sneaky over here is the X value. X value is any value that is being expired, anything that is about to die. It can stand at left and it can stand at right. If it stands at right, it can be moved into left one. You know that because it's a temporary thing that is happening. If it's standing at left, you need to know that when it's set, it might die afterwards and go to waste, or be converted to an L value. Okay? So X is an L value. Okay? It refers to a memory location. X plus 5, the result is a PR value. It has no memory location. Okay? But it's being set into Y. And the one that result of X plus 5 materializes into an X value, it means it actually has no location, and it will it will actually materialize into an X value Z, but when this line is over, Z will still exist like a regular L value. The problem that we have with students is that they think if you put 2 ampersands that you create actually an R value reference over here. That reference becomes a temporary thing. That's not the case. That is only to recognize what is coming in, and that's it. If I put over here a reference Z, it could not accept it because it doesn't have a memory location. But when you are making it an R value reference, it essentially tells move whatever over here that comes over to Z, but afterwards when we reach to this line, Z is just the reference, just any reference. So remember, any type of 2 ampersand that you create, they are just references, like they are identical. They work exactly the same way. The only difference is that you can catch R value, X values using the double reference, and that's it. Operator precedence. My daughter is learning it right now in grade 7 or something. So you know that multiplication happens first, parentheses around, prioritize and things like that. We know that, but it gets much more complicated. That's why I have the list over here. Whenever you don't know which one is happening first or last, look at these. These are all the operators that we have, and the operators you have, this is the precedence, which one happens first, and from left to right, or from right to left occasionally. Okay? Please go through them. Postfix expressions, weird because, oh, sorry, that's the subscription operator. Subscription operator essentially is a number that is getting added to the address of the value that is coming in. If you overload it, then it becomes completely an overload. But the original one is just the address that gets added to the address that you have in here. So if this is an integer, the address of 2 integers will be added to A, and the target of it will be extracted. Member selection, either with a dot or an arrow. Dot is a reference, arrow is a pointer, always at left. Postfix increment and decrement. For overload, you have to put an integer inside the thing when you're overloading. Other than that, this is a unique thing. The only thing that doesn't match math in operations that we have, because we don't have any postfix operators in math. Prefix expressions, same thing. They have side effects, and they return the value. When you are using the built-in type and you do plus plus, it happens after the statement. And when it's before, it happens before. But when you're overloading it, you're responsible to do that. It doesn't happen automatically. Unary operators, size of is one of them. It just takes the size of the operand that it have. It comes before the name, the operand. Logical operators work exactly like regular operators. They always return a value, but the value that they return, it's either true or false, which is 1 or 0. Address of and indirection. The address of extracts the address of entity. Indirection receives an address and extracts the value of the targeted address. Casts, please do not use old-fashioned style casts anymore. Use static cast, dynamic cast, reinterpret cast, or static, dynamic, reinterpret, and what was the other one? Static. What was the other one? Constant cast and constant cast. So use these, please. Do not use just old-fashioned cast, because that's not the way it's supposed to be used. The problem is that when you use the old-fashioned cast, it doesn't check to see if the cast that you are doing is actually what you want. When you're doing these 4 templated casts, you are specifically mentioning to the compiler what type of a cast that is being done. If what is happening is not what you asked for, compiler won't allow it. Binary expressions, relational expressions, they are exactly like binary. I wouldn't put them in 2 different categories. The only difference is that relational compare, but the returned value is true or false. Short circuit works like this. I always apologize at this moment because I don't draw well, especially with a mouse. So let's say this is a light that you can go on and off. And then you have one switch over here. and you have another switch over here, and you have a battery, and you connect it to that one. This switch is called A, this switch is called B. Now, if switch A is off, do I need to check switch B to see if the light goes on or not? No, the circuit is broken, right? It doesn't work. That's for AND. In this case, so let me just give you an example for it. Oh. Let me give you an example for it. Where are we? So this was B array template main.cpp. Okay. Let's say I have a million numbers in an array, okay? You see array A, integer A, it has a million elements. And I want to find out how many negative values I have in them. I can write an if statement, write if something, add to the value of the negatives. But using the short circuit or the old names for his lazy evaluation, I can do it much faster. To look at line 12, it's nothing but a logical AND expression, correct? So compiler tries to evaluate this. It starts with the first one. It says, is A less than B? Now, if A less than B is true, what happens? It means switch A is closed, right? Now, it needs to know if B is closed or not for the entire thing to go true or false, right? Therefore, it evaluates the right-hand side. Therefore, that will be added by 1. Then comes the next one. Now, let's say this is greater than 0. It means this is false, which means switch A is off. When switch A is off, it doesn't even need to check the second one. Because of that, it won't happen. This is called short circuit or lazy evaluation. Now, we have the exact same thing for OR statements. OR statements work like this. So you have a light, again. Man, I'm good. Okay, and then you come over here, and it comes down, and it comes over, and it goes like this. So you have one switch over here, and you have another switch over here. You have a battery, and you have a light. This is A, and this is B. Okay? For an OR switch, if A is closed, then we don't need to check the second one because it's closed and it's going to go on. But if it's not closed, then I have to check the second one to see if it goes on or not. So now, if I actually want to check and find out how many positives I have, I need the reverse thing. So if I say A less than 0 or positive plus plus, what happens is that if this condition is true, it will check the second one, correct? Which means if it's true, it will not check the second one. Therefore, if this is negative, this is not going to be added. And if it's false, and if this thing actually goes false, then it has to check the second one. Therefore, 0 and positive ones will add to positive. Good? Are we good? That's lazy evaluation. Assignment, we know, either assignment or plus equal. They're all assignments, but this one has side effect and adds the value of 2 to the other one and then passes through. So it works the same way. We have a comma operator. Comma operator, you can put 2 statements in one place. You will see later on when we're going to go to, there are crazy stuff when we're talking about scopes, you'll see exactly what it means. But when you do something like this, essentially it means first do y equals to 5, and then y plus 2 will happen and evaluate it and pass through. So the first one you're writing happens first, and then the second. If you want any time something like this happens, that's how you do it. You do it in for loops all the time. In for loop, you write for I equals 0, comma, b equals to the comma, and then semicolon condition, and semicolon condition. You can have many things. That's that one. Ternary expression. The only thing that I think most of people for some reason have forgotten is that in ternary operators, the true or false statements must be of the same type. You cannot have two different types over there. Okay? So the true statement, -1 and 1, they're both integers, so we are fine. And that's expressions. Okay? Again, please go through it, see if there is anything missing, let me know. We talked about questions about this. Suggestions? Objections? All right. So next thing, knowing about so this one is going to be okay. Now, we talked about composition, aggregation, and association. Association was when two classes had relationship with each other, but one had no role in creating or destroying the other one. An example for association could be implemented as follows. We talked about student and teacher, you see that? So student string name, as you see it has a name, and student can get created on its own anytime you want. A teacher has a name of its own, and it has an array of students of 45. So they are either null, or they can point to a student object. When you create a teacher, the array of students is empty. Now, when you add a student, you don't create a student. A student must be created outside, and the address is passed to the teacher collection. So teacher will keep track of its students and keeps adding it to it. Therefore, when the teacher goes away and dies, all the students outside remain intact. There is no interference. This is association. In aggregation, the difference is that when you are actually dealing with aggregation, the objects exist outside, but aggregation creates a copy of the objects in itself. So it's like a book in library. You have books outside. When a library wants to have it, it gets a copy of that book. When the library is gone, all the copies are going to be gone. If the library wants, it can change the contents of the book. It can add comments to it, it can stamp it, do whatever it wants to do. The main copy is not going to change outside. And when the library is gone, all the books inside the library will go to garbage. It's going to be gone. But the books outside exist. That's an aggregation. So it's a little more strong than association and weaker than composition. So I have book, and again, I have an array of book pointers, but the difference over here is that when I add a book, I don't get a pointer of the student out there. I get a reference to a constant book, and I make a new copy out of that book and keep it in my books. And when I'm done, all the books will be deleted and gone. So the composition destroys its own copies, but the original ones stay outside. Are we okay with this? Composition. With composition, the example was room and a house. If you look at the classroom, the constructor is private, which means no one can instantiate a room. Room cannot exist out there. It's the job of the house to build the room and add it to itself. So you have a room, it has a name and everything good, but house is its friend, which means it's its owner. When we are coming to a house, we have a house and we have a pointer of rooms again, no problem with that. But when we are actually adding a room, we get the ingredients to make the room with. So add a bedroom to yourself, add a kitchen to yourself. Therefore, it gets that one. Using that ingredient, it will create a new instance of room and keep it in itself. Through a house, you can access a room. But outside, you cannot create a room by itself. House is responsible for it. It is composing the rooms. And when it's gone, it's going to wipe out all the rooms and delete them. The difference between composition and aggregation is that it's more strong than aggregation. Aggregation it creates copies of already existing stuff, but composition will essentially build its own. Now, I created, once I wanted to create an assignment. It got a little too complicated and I said, forget it. So I now am using it as an example. So, and you'll be the judge. Give me a second. Okay, so I'm going to add a new project to this. Existing project. Okay. This is what I have here as my class diagram. Hide subcontent is a manipulator which can be inserted into OStream, and an IOable can be inserted into it. So you can insert an IOable into hide subcontent. If you just an IOable can be inserted into OStream too. If you insert an IOable into OStream, it will show everything that it has and all its contents. But if you insert an IOable into hide subcontent and then insert it to OStream, it will only show the title and not show the content of the. Then, out of IOable, I created a library and a book. Why did I create that hide subcontent? Is that my library can have books. A book can be in a library. So when I'm showing a library, it not only shows the library, but all the books that exist in a library. When I show a book, it not only shows the book, but it shows all the libraries in which you can find the book. It becomes chicken and the egg. So if I show a library shows itself and wants to show the book. When it shows the book, now book wants to show all the libraries that it appears in. And then the libraries again wants to show all the books. And the books wants to, so therefore it becomes an endless loop. Okay? That's why I have a hide subcontent. So when I can make sure that that doesn't happen. How it's programmed. IOable, I can display, read itself, or it can hide its subcontent. that's a function when you call, it hides it, okay? And it has a virtual destructor. It is insertable to IO stream. Then I have hide subcontent. First, I need to know in which O stream object I am hiding. Number two, this actually sets that. So this set OS sets that one, and you can insert this hide subcontent into the operator. Obviously, when you can insert an IOable into this. That's why it has a method. It's not a helper. It's a method that accepts an object. So an IOable object can be inserted into this manipulator. Manipulator receives that one and then transfers it out to OStream the way it wants. That's how manipulators work. They receive an object, they manipulate the object, they pass it out to whatever they want to pass. So, yeah. And this is externing the global, making a hide subcontent global. How it works, I create an instance of it. In here, and I make that instant available everywhere. So you can use that as a manipulator. So that manipulates everything. So now, I'm just going to show you the book. So yeah, the book has a title. It has an ISBN. It has an array of library pointers. Number of libraries, and it has a flag to hide the next print or not. Hide the libraries in next print or not. It cannot be copied or assigned to another one, and I did not do the rule of 5 on it. At the time, it was explained before that, but so I did it this way. You can add a library to it. You can add the library using insertion operator. You can hide subcontent. You can remove it from a library, and so on and so forth. And the library works the exact same way. So when you look at the library, it is the exact same way. Title, books, number of books, and so on and so forth. Okay? Everything's exactly the same. So main looks like something as follows. First, I have a show. The type T over here is a pointer to an array point. So it's a pointer to a pointer, a template of a pointer to a pointer, or pointer to an array. That's less confusing. So I create over here an array of pointers that you see that is library, and I put all my libraries in it. So I created 3 libraries. I make it 4, and 1, 2, 3. 3 will go in here. The 4th one becomes null. Therefore, it becomes a null terminated array of library pointers. Now I have B over here. That becomes a null terminated array of book pointers. So I have these 2. Now if I show the library or show the book, it just shows the library and book. Using insertion, I am adding the books one by one to the libraries. And then I show everything again, and you'll see what happens. So when I run this code, oh, sorry, wrong project. Stop. Set as startup project. One more time. All right, so the libraries are created, books are created. They're packed in an array. Now I'll pass the library, null pointer library to show. So it goes to show, it prompts library list, that one. Then it shows the first library, goes to the next one, goes to the next one, goes to the next one, until the pointer is null and comes out. So all the libraries are shown. Now it goes to the book list. Prompts, these are the book list, goes to first book, second book, third book, fourth book, and go to the last, and comes out. Now I'm going to insert these books in a library, and now I'm going to show the libraries. As soon as show it, it shows all the books in the library that are available. Now if I show the books, it goes the other way. It shows that this is C++ reference, and it is available in following libraries, so on and so forth. So it's essentially a relation between a book and library. Now you decide what type of relation it is. Is it an association, aggregation, or composition? We good? Please walk through this code. This is, I'm not going to say very complicated, but it's a much more complicated code that you've seen, and it doesn't have anything extraordinary in it. All the things that you see is covered. Pointers, pointer to pointers, templates, function templates, and classes, insertion, operator overload. All the good things are in here. Please walk through it step by step using Visual Studio. Try and see how it works, and if you hack this code, you'll be okay. Okay? I have sent feedback to your workshop, to your quiz 0. This is a very pessimistic feedback. If you look at it, I think the average of everyone is like less than, like the average of class is around less than 5. So that shows that either the knowledge of C++ is gone off your minds, or you don't have much experience in programming. Please, this is the time if you need help. I don't know if I can do this, but I am asking. So please think about this. When you come to lab, I'm going to ask the question, would you like me to have a crash course on OOP345 concepts one weekend? We start at, I don't know, 9 o'clock in the morning, and we go to 3 o'clock in the afternoon, and I'm going to cover the whole concept of C++ and object orientation quickly, so you can catch up with this. Think about it. I'm going to ask the question when you're coming to lab. If majority of students want it, I'll do it, but I'm going to ask you to register, because I don't want people to say yes and I come and I see 3 people in class. I want to make sure everybody's there. Okay? Questions?
So this Thursday we are having a quiz on Thursday.
Hopefully.
Okay.
Yeah.
And you mentioned a lab, but I saw something released on.
We have a lab, right?
Well, I know you mentioned it, but I didn't see anything come out on Blackboard.
What are we talking about?
Is there a lab for this weekend? Due or something?
When you say lab, what do you mean?
An assignment.
Oh yeah, assignment 1 is up for a long time now. It's in the assignments.
Okay.
Yeah, and please, I would never ever say that you should go on that repository and add yourself to the watch list.
Okay.
So if anything's added over there, you'll know. Okay? But if you need extension for it, you have to let me know. I don't mind giving extensions as long as you do it yourself. Okay? So if you need extension for it, these are very open-ended assignments. So if you need extension for it, try to do it on time. And if you see you're behind, you can't do it, you let me know, and I'll help you. You can submit. Okay? Any other question? Let me see if there's any questions in here. Any questions, online people? No? All right. Thank you, and have yourself a beautiful day.